Good evening, everyone. So, as usual, we will wait for a couple of more minutes and we will start by 6:02 or 6:03. Okay. Hope I'm audible and you're able to see my screen. Today, we will discuss 5 questions. I hope we can finish 5 questions today, all related with probability theory. Okay. So, some of them are fairly simple, as you can see one question in the screen. So, okay, we will wait for one more minute and we will start. I'm audible, right? Yeah, thanks. Okay, let's start. So, the first question is as follows. Suppose A and B are two independent events with probabilities P of A and P of B, where P of A not equal to 0 and P of B not equal to 0, and let A bar and B bar be their complements. And 4 statements are given, and out of the 4 statements, one statement is false, and we need to find the wrong statement. Yeah, already people are answering. So the answer to the question is C. As you have commented, it's C, which is correct. But anyway, let us see all the other options. And all the other options are related, or at least the first and second options, option A and option B, have some significance. Okay. So option A is nothing but the definition of two independent events. If events A and B are independent, then the intersection A intersection B, the probability of the event A intersection B is nothing but probability of A into probability of B. Okay, and this option B comes from the definition of conditional probability. So for two events A and B, the probability of A given B, the conditional probability of A given the event B is defined as the joint probability or the probability of A intersection B divided by probability of B. When A and B are independent, you can write the numerator as P of A into P of B, and in the denominator there is already one P of B which will get cancelled out, and it is equal to P of A. And regarding option D, P of A intersection, A bar intersection B bar, that means the complement of events A and B and the intersection of those two events. So basically, if A and B are independent, then A complement and B complement are independent. This you can show as follows. So A bar intersection B bar can be written as A union B, the whole bar, or the complement of the event A union B. This is coming from De Morgan's law. So this can be written as A union B, the whole complement. Okay. So similarly, one more De Morgan's law is there. A bar union B bar is nothing but A intersection B, the whole complement. Okay. So this you can write as 1 minus probability of A union B, and here probability of A union B can be written as probability of A plus probability of B minus probability of A intersection B. This is inclusion exclusion principle of probability of, or inclusion exclusion principle of events. Okay, so probability of A plus probability of B minus probability of A intersection B. Again, since A and B are independent, this probability A intersection B will be equal to probability of A into probability of B. So this is equal to 1 minus P of A minus P of B plus P of A into P of B. So this part I can write as probability of B into 1 minus probability of A, correct? Including this minus. So this is nothing but 1 minus P of A plus P of B into, minus P of B into 1 minus P of A, right? So this is only this part. So which can be written as 1 minus P of A, I can take outside, into 1 minus P of B, which is equal to P of A complement into P of B complement. So what does this imply? When A and B are independent, A complement and B complement are independent. So the only remaining one is option C. As you know, P of A union B can be written as probability of A plus probability of B minus probability of A intersection B in general. This is inclusion exclusion principle. So at the max, you can change this probability of A intersection B into P of A into P of B if they are independent. So option C is false. So the answer to the question is option C. Okay, so I hope it is very straightforward and everybody knows this. So I'm not going for any more explanations. So now let us see the next question. Okay, this is again a question from 2014, if I remember correctly. Okay, so the question is as follows: an unbiased coin is tossed an infinite number of times. The probability that the fourth head appears at the 10th toss is. Okay, can somebody tell the answer if you know? It's also not very difficult. It's fairly straightforward question. Okay, then let us solve this. So there is an unbiased coin. What does that mean? If I toss that coin, then the probability of the outcome O being head is equal to half, and probability of the outcome O being tail is also half. That is the meaning of unbiased coin. Okay, so what am I doing? I'm doing an experiment. I'm tossing the unbiased coin infinite number of times. So we need to consider only the first 10 tosses. Okay, and the question is to find the probability of the fourth head being appearing exactly at the 10th toss. Okay, so 10 tosses, fourth head appears exactly at the 10th toss. So what does that mean? If I consider the first 9 tosses, so how many tosses would be tail? Number of tails. How many of them would be tails? So consider this scenario. Fourth head appears at the 10th toss. Then if you consider the first 9 tosses, the number of tails would be 6, correct? And number of heads would be definitely 3, correct? So in the first 9 tosses, there should be exactly 6 tails and 3 heads. And what more? In the 10th toss, it should be a head. Right? That's the meaning of this, right? The fourth head appears exactly at the 10th toss. That means in the first 9 tosses, there should be 6 tails and 3 heads, and the fourth head should appear at the 10th toss. Right? So first we need to find the probability of this event. From the first 9 tosses, you have to get 6 tails and 3 heads. So let us call this event as say A, and event B I am defining as the 10th toes being hit. What is the probability of B then? So this is 10th toes is NH, right? So what is the probability of this event B? That is nothing but half, right? So we need to find the probability of A intersection B, or in other words, you need to find the probability of A into probability of B, because these two events are independent, correct? Or basically you need to find the probability of this particular event, and you have to multiply with the probability of this event, which is being half. Clear? So now what is the probability of happening this A? What is the probability of this? So can somebody tell the distribution that it follows if you are tossing a coin for n times? Anyone? Yeah, exactly. It's a binomial distribution. It will be a binomial. It is a binomial distributed random variable if you're expressing it as a random variable. Okay. So what does that mean? So you do not need to worry about the term binomial distribution if you're unaware of that. It's pretty simple if you're considering 9 tosses. Okay. In that, you have to get 6 tails and 3 heads. So basically, you need to count how many number of ways this can happen, right? So I will write an example. So T, 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 T. First 6 tosses are tails, and the next 3 are heads. This is one possibility. You can have lots of possibility. What is the probability of this? This is being say if the probability of getting a tail is say P, and probability of getting a head is, it will be definitely 1 minus P, right? So probability for this event will be nothing but P power 6 into 1 minus P cube, right? So this is one way of getting 6 tails and 3 heads. So there are some number of ways you can happen this, or there are, so the question is, or the binomial distribution tells you in how many number of ways this particular event can happen. Sorry, this particular event can happen. Number of tails equal to 6 and number of heads equal to 3. That is nothing but, you can see in this case, out of 9, it has to be, so you have to have 6 tails, right? So you can choose, so there are 9 positions, 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of these 9 positions, you have to fill 6 T's. So the remaining 3 will be definitely heads. So in how many number of ways you can choose that 6 positions from the available 9 positions? That is nothing but 9C3, or 9 choose 3, which is equal to 9 into 8 into 7 divided by 1 into 2 into 3. So the probability of n of t equal to 6, comma n of h equal to 3 is equal to 9 choose 3 into 0.5 power 6 into 0.5 power 3. Any question? So this is nothing but 9 into 8 into 7 divided by 1 into 2 into 3 into 1 by 2 power 9, right? So this is equal to, so this will get cancelled out. So 12 into 7, which is 84 by 2 power 9, which is equal to 512. So this is the probability of getting 6 tails and 3 heads in the first 9 tosses. And there is one more probability that you have to multiply the probability that we got, which is the probability of getting a probability of getting a head in the 10th toss, which has probability 1 by 2. So the required probability, or the probability of the intersecting event A intersection B, is nothing but 84 divided by 512 into 1 by 2, which is equal to 84 divided by 1024, which is approximately equal to point, how much, 0.82. So the answer to the question is option C. Any questions? Any doubts? If you have some question, you ask now. Any questions regarding, any doubts regarding the solution? If you have some questions, you can ask now. Is it clear to everyone? Okay. Is it okay? Then let us proceed to the next question. Okay, great. So if you have some questions, you can ask at the end of the session as well. Okay. So now, yeah, a slightly different kind of question. It's not uh, as straightforward as the previous question, but it's not a difficult one. It's a fairly easy question, but it's a slightly different pattern. The question follows a slightly different pattern. Okay. So it's a one line. The question is just a line. Let capital X be a zero mean unit variance Gaussian random variable. Then what is the expectation of mod X or the absolute value of X? It's a numerical answer type question, and yeah, so you need to work out and you need to give the expectation of the magnitude of X. Okay, before getting into the solution, let us see some preliminaries or some tools that are required to solve this. First of all, what is a Gaussian random variable? Okay, how do we represent a random variable? So there are, if it's a continuous random variable, just like Gaussian random variable, we will have either a PDF, probability density function, or a CDF, cumulative distribution function. Okay, so usually this Gaussian random variable, sometimes we will call it as normal random variable. Okay, Gaussian and normal are interchangeably used. It is usually described by its PDF. Okay, the PDF of the Gaussian random variable is denoted as fx of x. This capital X denotes the random variable, and this small x denotes the realization or the value that it can take. Okay, so this is equal to 1 by root 2 pi and sigma square inside, or you can take sigma square outside and you can write it as sigma. Okay, e power minus x minus mu the whole square divided by 2. Okay, this is the PDF or the probability density function of Gaussian random variable. And there are two parameters, right? Mu and sigma square, where mu is the expectation of X or the mean of the random variable, which is mu. Okay, and the variance of the random variable is nothing but sigma square. So there are two parameters in the PDF. Those are nothing but the mean and the variance of the random variable, which is Gaussian. Okay, now in the question, it is told that X be a zero mean and unit variance Gaussian random variable. What does that mean? Zero mean means mu equal to 0. The mean is 0. And variance, sigma square equal to, it's a unit variance means it's 1. Okay. Then what will be the PDF? The PDF or the probability density function fx of x equal to 1 by root 2 pi, okay, expectation of, sorry, e power, this is exponent, e power minus x square by 2. Is it clear? This is the PDF of a zero mean unit variance Gaussian random variable or a normal random variable. Okay. So if you see literature or if you see some textbook, there are few random variables that will be heavily described in the book or in the textbook. One of them will be definitely Gaussian random variables. If you see some textbooks, you may even find a chapter on this Gaussian random variable. Okay, it has great significance in a lot of areas. So one reason that most of you might have heard at least is of central limit theorem. If you add lot of independent random variables, the resulting random variable or the say you have plenty of random variables x1 x2 up to say it goes like that. So if you're summing up x1 x2 up to xn and assume that it's a all these are independent random variables and this will tend to a Gaussian random variable. Okay, if this n, as this n goes to infinity, this will become Gaussian, this x will become Gaussian or normal. Okay, that is one significance. So this is known as central limit theorem. So okay, and there are plenty of other reasons why we go for this Gaussian random variables. Okay, and you might have seen the PDF at least in the picture. So say assume that it's a zero mean Gaussian random variable. It's symmetric. My drawing is bad. So this is symmetric around x-axis. Okay, now at least, yeah. So if it is not zero mean, then the peak will be at mu, x equal to mu. Okay, and this is fx of x. So for a continuous random variable, you cannot have the probability for a single point. Okay, so what is the probability of a Gaussian random variable being zero? It is not this value, that is actually zero. Okay, you can have probability defined for an interval. What is the probability of x less than or equal to a less than or equal to x less than or equal to b? Say here we have a and here we have b, then the probability is nothing but the area under that probability density function. Okay, so these things are not needed to solve this problem, but if you see some other problems from GATE, you may encounter these kind of problems. Okay, to find the probability of x being between some a and b, that is nothing but the area under the probability density function. So yeah, so that is about PDF. And now let us come back to the question. Yeah, and it's asked to find out this particular expectation of the magnitude of x. Suppose x is some random variable, okay, and g of x is a function of that random variable. X has a PDF f of x. Okay, sometimes I will write capital X as a subscript. Okay, then what is the expectation of g of x? Now we have g of x equal to the magnitude of x or the modulus of x, right? So expectation of g of x is nothing but integral minus infinity to infinity g of x into fx of x dx. So far so good. Now if you have g of x equal to say simply x, g of x equal to x, then expectation of g of x will become expectation of x. This is nothing but the mean of the random variable. Now if g of x equal to say x minus mu the whole square, okay, expectation of x minus mu the whole square, which is nothing but the variance of x. If you have g of x equal to, say, some x power n, where n is a positive integer, okay, a non-negative integer, then expectation of x power n is nothing but the nth moment of the random variable. So now we have neither of these. We have something completely different. G of x equal to modulus of x. Now let us find out that. So now it boils down to finding this integral. Okay, it's not very difficult. The expectation of the magnitude of x equal to integral minus infinity to infinity modulus of x into fx of x dx. So let us quickly do this. Integral minus infinity to infinity magnitude of x into 1 by root 2 pi into e power. So sigma square is 1 minus x square by 2 into dx, where mu equal to 0. It's a 0 mean unit variance Gaussian random variable. So let us take this 1 by root 2 pi outside, and we can split this integral into 2. Okay, if x is in between minus infinity and infinity, modulus of x is nothing but, so modulus of x will be always positive, right? How is modulus of x defined? Modulus of x equal to minus x if x less than or equal to 0. Modulus of x equal to x if x greater than or equal to 0. So it has a, this is the graph of modulus of x, right? So now let us split this integral into 2 using the definition of this modulus function. So integral minus infinity to 0, modulus of x will be minus infinity in that range. So e power minus x square by 2 dx, correct? Plus integral 0 to infinity in that region, modulus of x is nothing but x, e power minus x square by 2 dx, correct? So which is equal to 1 by root 2 pi into, what is this integral? First, let us consider this. Both of them are same. There is only a matter of a minus symbol and the limit, correct? So we can use a simple trick here. So you see this d by dx, or the differential of e power minus x square by 2. What is this? If you use chain rule, we will get e power minus x square by 2 into minus x, right? Or minus x into e power minus x square by 2 is the differential of e power minus x square by 2, correct? Or in other words, integral x e power minus x square by 2 dx equal to, or minus x e power minus x square by 2 dx equal to what is the value? That is nothing but e power minus x square by 2. Any doubts? It's clear, right? These are inverse operations. So this integral is nothing but 1 by root 2 pi into, so this integral is nothing but, directly there is a minus, so we can write e power minus x square by 2. So e power minus x square by 2 over the limit minus infinity to 0, correct? So here, if I insert a minus here, I will put a minus outside. So this is nothing but minus e power minus x square by 2 integrating from 0 to infinity, or the limits are from 0 to infinity. So this is 1 by root 2 pi. So let us substitute the limits. So if I substitute x equal to 0 in the first, let us focus on this. Okay, if I substitute 0, we will get e power minus 0, which is 1, and e power minus infinity, which is again 0, correct? Because minus infinity square in the limiting case, anyway, this x square will be always positive, right? So e power minus infinity is nothing but 0. So again minus. here you will get 0 minus 1, because here e power minus infinity is 0 minus e power minus 0. So now what you have is nothing but 1 by root 2 pi into 2. Or in other words, it's equal to root 2 by pi. So I don't know the value of this. Let me calculate. Okay, root over 2 by pi. It will be around 0.8. It's equal to 0.798. So the answer to the question is 0.798. Any doubts? If you have some questions, you can ask now, or you can ask towards the end as well. But it's better to ask if you have some questions, so that all of you will benefit. Any questions? Any doubts over this final integration, or maybe in between something? Is everything clear? Can we go ahead? Okay. So far, so good. So now it's a fairly straightforward question. Okay. So you can tell the answer if you know. Directly you can tell the answer. Okay. Okay, the question is as follows. Let capital X be a real valued random variable with expectation of X and expectation of X square, denoting the mean value of X and X square respectively. The relation which always holds true. Okay. So it's, how will we proceed? So there is a simple trick or one definition that you have to use here. Is anybody attempting? So at least you can tell A, B, C, D. Okay, anyway, I will solve this. So I have defined the variance of a random variable in the previous, here we have defined variance of X is nothing but the expectation of X minus mu the whole square, right? So now what can you tell about variance of X? Can it be a negative number? Can variance of a random variable be a negative number? It is not possible, right? Because X minus mu, the whole square will make it always a positive or a non-negative number, correct? So expectation will also be a non-negative number, or in other words, variance of X is always greater than or equal to 0. So this is the idea that you need to use here, okay? And mu is nothing but expectation of X. So variance of X is equal to expectation of X minus mu is nothing but expectation of X itself, right? Whole square. So what is the expansion of A minus B whole square? That is nothing but X square. I am expanding this term, X minus expectation of X whole square, okay? X square minus 2X into expectation of X plus expectation of X square, correct? Which is equal to, expectation is a linear operator. In other words, this you can write like this, 2 expectation of 2X into expectation of X plus expectation of X square, correct? Which is equal to expectation of X square minus 2 times expectation of X into expectation of X, because 2 and expectation of X are constant numbers. This and this are constant numbers. So here again, expectation of X, the whole square is also a common, it's a constant. So you can write this as expectation of X square. So this is nothing but expectation of x square minus expectation of x whole square. Everything good? Is everything straightforward? So now what can we do? We know that this is always greater than or equal to 0. What does that mean? Expectation of x square is always greater than or equal to expectation of x the whole square. So what is the answer? The answer to the question is nothing but option B. So far so good. Any questions? So this you can take as an alternative definition for variance of x. Okay, this part, variance of x is nothing but expectation of x square minus expectation of x the whole square. This will be very handy to solve a lot of questions. This you will see again in the next question. This small idea you can use straightforward. Okay, otherwise you will have to define everything, you have to derive everything again. So now I have one small question. At what condition these two will become equal, or in other words, for which random variable these two are same? So these two are same means this difference is equal to 0, or in other words, variance equal to 0. For which random variable the variance is 0? It's not really random. Can somebody tell? Variance equal to 0. Okay, if x is a constant, say x equal to c, for some constant c, then the expectation of x is nothing but c itself, and the variance of x equal to 0. There is no variance. First of all, what is the physical meaning of variance? So a random variable, on an average, how far a random variable can differ from its mean. That is the meaning of this. Expectation means on an average, how far this random variable x can differ from the mean mu. Okay, that is the meaning of variance. If x is a constant, then there is no variance, right? There is no differing from the actual mean. Mean is the constant itself. There is no variance. So variance is 0. In that case, expectation of x square will be equal to expectation of x the whole square. In all the other cases, for all the other random variables, variance of x will be non-zero. Or in other words, this will be strictly greater than this. This equality will not happen. Okay, is that clear? Okay, so can we go ahead to the next problem? Yeah, good. So one last problem. I think today we are running ahead of time, but still this is not like very straightforward one. It's not difficult, but it takes a few minutes to solve. Okay, so the second moment of a Poisson distributed random variable is 2. The mean of the random variable is. So if you know the mean and variance of a Poisson random variable, then this is very straightforward. Okay, and otherwise it requires some time. Anyway, you will require to like, by heart these mean and variance of different distributions when you're going for gate exam. You won't get time to derive all this stuff. Okay, but still I can derive. Now we have some time. So yeah, first of all, how is Poisson distribution different from Gaussian distribution? There are two different distributions, that I agree, but other than that, what is a major difference? Yeah, exactly. So this is a discrete distribution. The previous one, the Gaussian distribution, was a continuous distribution. So you had PDF. correct? Now you will have PMF, probability mass function. Okay, usually we denote that with Px of x is the PMF, probability mass function. Probability mass function. Here you can have probability defined for a discrete point. In the previous case, you have seen that it's 0 for a discrete point, correct? So you will have probability for an area. So we have seen A less than or equal to X less than or equal to B, correct? That's the area under the probability density function. Here in this case, you can have probability defined for a single discrete point, okay? And this Poisson distribution, the Poisson random variable, first of all, X, can take the values 0, 1, 2 up to infinity. It can take any any non-negative integer values. Okay, now what is the probability of or Px of x equal to k? K can be any non-negative positive integer. This is nothing but the PMF. So this is equal to lambda e power minus lambda into lambda power k divided by k factorial. So this is the probability of the random variable x taking a non-negative integer value k. Okay. So here lambda is a parameter. Okay. So in fact, the lambda will be the mean of the random variable as well as the variance of the random variable. That I will show here. So before that, you have to verify one more thing, right? Probability of x equal to k equal to 0 to infinity. What should be this probability, or what is the sum of these infinite probabilities? Can somebody tell? What should be this value? Yeah, exactly. It should be equal to 1, right? Because total probability must sum up to 1. So let us verify that first of all. Summation k equal to 0 to infinity e power minus lambda, lambda power k divided by k factorial. So e power minus lambda is, it can be taken outside, right? Because e power minus lambda does not depend upon k. So what is this sum? So you can easily tell this must be equal to e power lambda. This is in fact equal to e power minus lambda. This is the definition of the exponent e power lambda or e power x equal to summation k equal to 0 to infinity x power k divided by k factorial. Okay, or this is a property. This this property may be useful to solve other problems as well, right? So e power x equal to summation k equal to 0 to infinity x power k divided by k factorial, or in other words, this is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. Okay, so this is the definition. So if you use that, you will get this is equal to 1. So in order to calculate the mean and the variance of the Poisson distribution, you will have to use this property again and again. Okay, so now let us find the expectation of Poisson random variable. So the expectation of Poisson random variable, expectation of x, in this case for a discrete random variable, the expectation of x is defined as nothing but n equal to minus infinity to infinity n into, okay, p of x equal to n. So this is how for a discrete random variable the mean is defined. Okay, or in general you can have there is a slight problem with this definition. I will redefine this because this will not be useful in many cases. Say x is a discrete random variable. X can take values, say x1 x2 up to x some capital K. Okay, then the expectation of x is nothing but summation some small k running from 1 to capital K, x small k into probability of x taking value x small k. Okay, so this is a more general definition. In this case, now let us come to Poisson distribution. In this case, we have expectation of x equal to, so it can take, the random variable can take all the non-zero integer values, right? From k equal to 0 to infinity, it can take k into probability of x equal to k, or in other words, px of x equal to k, right? Because in this case, the random variable, the Poisson random variable can take values 0, 1, 2 up to infinity. So now let us calculate this. Summation k equal to 0 to infinity k into e power minus lambda, lambda power k divided by k factorial. So this k and k factorial will be, so this can be written as k equal to 0 to infinity e power minus lambda, lambda power k divided by k minus 1 factorial, right? So now I can take e power minus lambda outside and 1 lambda outside, lambda e power minus lambda, summation k equal to, so now 1 to infinity, because k minus 1 factorial, k minus 1 cannot be a negative number, it has to be at least 0. So e lambda power k minus 1, because I have taken 1 lambda outside, divided by k minus 1 factorial. What is this? This is nothing but e power lambda. That is the definition. By this definition of e power x, this is equal to e power lambda on this part. So lambda e power minus lambda into e power lambda. So which is equal to lambda. Okay. So this is the mean of Poisson random variable. Now if you do, you will get the variance of Poisson random variable is also nothing but lambda. Okay, let us do that. Before that, variance of x, we have seen in the previous case, expectation of x square minus expectation of x the whole square. What does that mean? Expectation of x square minus, in this case, it is lambda square. Agree? Expectation of x is lambda. So now let us find out this expectation of x square. So expectation of x square, this is the second moment. In the question, it is given that the second moment is nothing but 2, correct? Yeah, the second moment of the Poisson distributed random variable is 2. Okay, anyway, we will come back to the question after doing this exercise. Expectation of x square is nothing but, just like the previous case, here it is x square, or in other words, k square into probability of px of x equal to k, and k runs from 0 to infinity. So just like the previous definition in the continuous case, you have to square the values that the random variable takes. Okay, so which is equal to summation k equal to 0 to infinity k square into e power minus lambda, lambda power k divided by k factorial. So summation, so what will I do now is that k square, it's a simple trick, k into k square can be written as k square minus k plus k, right? So this I will write as k into k minus 1 plus k. Okay, and I will split the summation into two summations. So summation k equal to 0 to infinity k into k minus 1 into e power minus lambda, lambda power k divided by k factorial, plus summation k equal to 0 to infinity k into e power minus lambda, lambda power k divided by k factorial. Can somebody tell this very quickly without calculating anything? What is the value of that summation? Somebody please tell. What is that, first of all? Isn't that the mean of the random variable? Agree? Disagree? So what is that sum? See, that is nothing but this sum, right? So what is the value? Can somebody tell? Please, otherwise I can't go ahead because I need to repeat the same thing again. Yeah, it is lambda. Excellent. So this part is nothing but plus lambda. Now, what is this? So this is nothing but k equal to 0 to infinity e power minus lambda, lambda power k divided by k minus 2 factorial, right? So k factorial, I'm writing plus lambda here. So k factorial means k into k minus 1 into k minus 2 into k minus 3. It goes like that, right? Or otherwise 1 into 2 into 3 into 4 into etc. up to into k is k factorial. So I'm just what am I doing? I'm just cancelling k into k minus 1. So we will get k minus 2 factorial. Now you can take lambda square and e power minus lambda outside, summation k equal to, in this case, uh, it will be lambda power k minus 2 divided by k minus 2 factorial. So this k starts from 2 to infinity plus lambda. I'm just making that adjustment in order to make sure that the denominator does not go beyond 0 factorial. Okay, 0 factorial is nothing but 1. So here it is lambda square e power minus lambda. And what is this sum? This is again e power lambda, right? That's the definition of e power lambda plus lambda. So which is equal to lambda square plus lambda. What is this? This is nothing but the second moment. So this is this expectation of x square. And in order to get the variance, you have to subtract 1 lambda square. That means lambda square will be gone and variance of x will be equal to lambda square plus lambda minus lambda square, which is equal to lambda. So Poisson distribution has a mean which is equal to lambda, and it has a variance which is again equal to lambda. Now it is fairly straightforward. Come to the question. The second moment of a Poisson distributed random variable is 2. The mean of the random variable is, so we have already calculated the expectation of x square, the second moment, which is equal to lambda square plus lambda. Lambda square plus lambda equal to 2. Correct? Lambda square plus lambda equal to 2. And it is asked to find out the mean of the random variable. Mean is nothing but lambda. So it's a quadratic equation, lambda square plus lambda minus 2 equal to 0, which means that lambda plus 2 into lambda minus 1 equal to 0. That means lambda equal to plus 1 or minus 2. So now what is the value? What is the final answer? Can somebody tell? Is it plus 1 or minus 2? Yeah, it's plus 1 because it cannot be a negative number, right? The Poisson random variable can itself be only non-negative integers. It cannot be a negative number because you are ultimately taking expectation of lot of non-negative numbers. So the expectation must be a positive real number. It can be a real number, it need not be an integer, but it has to be non-negative, correct? So the lambda or the expectation equal to is equal to plus 1. So the answer to the question is plus 1. Okay, so that's all for the day. If you have some doubts, you can ask now, or if you need me to do some questions very quickly, you can ask me. Maybe some questions from that we have discussed today, or maybe some questions that we have seen in the last week. Okay, 5 more or 4 more minutes remaining. So there are hardly 2 more weeks, right? Or maybe 3 more weeks before the gate exam. 2 weeks. Yeah. So we will have 2 more classes. If you need to discuss some specific questions, you can send me. Okay, you can send me a mail, or you can tell now that we can discuss in the coming classes. Uh, if you're not telling anything, we will discuss maybe again some mathematics questions related with engineering maths, maybe related with matrix, or maybe yeah, some linear algebra related questions. Okay, or maybe again some probability questions. So whichever you want, I can discuss that. Okay. Okay. DFT and DTFT. Okay. Yeah, I think we have done 2 sessions, right? Yeah, I can do that. So I don't have, like, we have discussed some questions. See, this is one of the questions that we have seen in the, yeah, in this phase, and in the previous phase, I have done some questions. If you want, we can repeat the same questions, okay? Or maybe slightly different questions we can take. Yeah. So this is one question. Yeah, discrete Fourier transform and discrete time Fourier transform, right? Yeah, that we will do in the next week. Anyway, we will discuss some math questions, and the next week we will do some DFT questions. Okay, next week I have already given the topic, so uh, that's why. Otherwise, yeah. Anyway, we have one more session after that, right? We will do discrete time Fourier transform or discrete Fourier transform. Cool.
Sir,
Any, yeah.
sir, can you take questions from convolution, circular convolution type,
Yeah,
discrete
yeah,
Fourier transform?
yeah. Sure. Yeah, circular convolution. Yeah, I'll do that.
Okay, sir.
Yeah. Okay, thanks. Okay, if there are no questions, we will wind up now, and we will meet again uh, coming Tuesday, 6 to 7. Yeah. Have a nice day. Bye bye.